And the basic idea with this tangent function is that this pattern is going to repeat infinitely many times, and we can start to see this. If we graph more points, we can confirm that. But at this point, let's just focus on this first interval between minus pi over 2 and pi over 2 and see if we can construct a little bit cleaner of a picture, since we need a couple more points to get a general idea of what's happening here. And we can look at values of pi over 6, pi over 3, and then the negatives to those angles. And we just need to keep in mind that a pi over 6 radian angle is a 30-degree angle, where pi over 3 radians is 60 degrees. And of course, for negative pi over 6, we have negative 30, and likewise for minus pi over 3, we have negative 60. And with these angles, we can build a 30, 60, 90 right triangle. And with that triangle, we know this triangle is actually half of an equilateral triangle. If this is 30, this would be 60. This is a 90-degree angle. And since this is really just half of an equilateral triangle, and we know the hypotenuse is 1, this is half of the hypotenuse. And if you use the Pythagorean theorem, you can determine that this would just be root 3 multiplied by the small side, or just root 3 over 2. And when we look at the tangent of, let's say, 30 degrees, or pi over 6 radians, we get 1/2 divided by root 3 over 2, which simplifies to 1 over the square root of 3, or if we rationalize it, root 3 over 3, which as a decimal is approximately 0.58. It is an irrational number. And we can look at the tangent of pi over 3, or 60 degrees, by looking at the ratio of root 3 over 2 to 1/2. We divide those, and we simply just get the square root of 3, which as a decimal is approximately 1.73. And we can also look at the negatives. That would essentially just draw the triangles down here. This would be the pi over 6 radian triangle, or angle, and roughly right about there, let me make it a little bit more accurate, right about here would be the pi over 3 radian angle. But the key idea that when we draw the triangle down here, the y values are negative and the x values are positive. So for this 30-degree angle, it would essentially just reflect downward, where the opposite side is negative, and we're dividing by this adjacent side, root 3 over 2, and we will essentially get the opposite of the tangent of pi over 6. We would get this minus root 3 over 3, which would be negative 0.58. And when we do minus pi over 3, now we're looking at the 60-degree angle here, and in that case, the side root 3 over 2, this long side, that would be the negative. So we have minus root 3 over 2 divided by 1/2, which would be negative root 3 when everything cancels out. So we can fill in minus root 3, which would be approximately negative 1.73. And let me quickly fill these in. And of course, we're approximating everything here, so it's not going to be the exact graph, but we can get a good idea of what it looks like. And with these points plotted, we can start to see the curviness here. It will essentially look something like this, but let me redraw that with a little bit more accuracy. And we can also repeat this pattern for each of these intervals. And if you want to prove to yourself that this pattern does indeed repeat for every interval of essentially pi radians, starting at pi over 2, we can add pi radians as many times as we want to recreate these intervals. To prove to yourself that the pattern does continue, I encourage you just plot points in these intervals between what we have and see for yourself that you will get the exact same curve. And you'll see with this picture that it's not perfectly accurate, but if you want to see an exact picture, I encourage you plot this using either a graphing calculator or some type of computer program, and you can see an exact picture of what the tangent function looks like, but it does roughly look like this here. And notice that as the angle theta approaches pi over 2, the tangent function shoots up to positive infinity. And as it approaches minus pi over 2, heading leftward in the negative direction, it approaches negative infinity. And this should make sense because as we move along the unit circle and get closer and closer to pi over 2 radians, notice that the x value gets smaller and smaller, the number we're dividing by, and the y value gets bigger and bigger. So this ratio starts to approach very large values as the angle approaches pi over 2, but it can't equal pi over 2 since this denominator will be 0.